So today we are going to study this new chapter known as work, energy, and power. So here we will be introducing three new physical quantities, which is work, energy, and power. And a lot of time in daily life we use term like work, like we are doing some work. Okay, but what is scientific definition of work? Similarly, we say that we are spending energy to do work. Then again, what is scientific understanding of energy? And also, what is scientific understanding of power? So we'll go one by one, starting with the definition of work. Work is any physical or mental activity which one does to perform daily task. However, in scientific parlance, work is done when a force produces motion in an object. See, though, like for example, if I'm studying right now, I can say that I'm doing some work. Okay. If I sit ideally and meditate, I can still say I'm doing some work. Okay. If I'm thinking hard on a problem, I can still say I am doing some work. Because in some form, like even if you're thinking, okay, you are spending energy because even that thought like the thinking process takes some energy from your body, so you are actually technically doing work. But when it comes to mechanical work in scientific terms, we only say work is being done when a force produces motion in any object. So that if you apply force on an object, until the force produces motion in the object, we say there is no work done. Okay, so or in other words, we can only say work is being done when a force acting on a body produces motion in a body. So suppose this is one object. If I try to move this object by applying force, okay, if the object moves, then we say we are doing some work on the object or work is done on the object. If the object doesn't move, then there is no work done on the object. The amount of work done depends on mainly therefore two factors. First is magnitude of the force applied and the direction of the force applied on the object. Okay, so it depends on magnitude and the direction as well. Okay, how it depends on the direction, about that we will cover in a while. But most importantly, it depends on the magnitude of the force, and it also depends on the displacement of the object. Okay, distance or the displacement of the object. The amount of work done by a force in moving a body is equal to product of force and displacement of the point of application of force in the direction of force. Suppose we have an object which is moving in the direction of application of force, like you are applying force in this direction and the object is also moving in the same direction. Okay, let's say this is displacement of the object. Displacement, we have learned from last year that we represent displacement with S. Work depends on two things: how much force we are applying on the object and what is the displacement of the object in the direction of force. Okay, so this is one case where the direction of displacement and the direction of force is in one direction. Work done is force times displacement. And next point is work is a scalar quantity. So we don't associate direction with work. So whether you are doing work in the right direction, left direction, north direction, east direction, we just say that we have done 500 joules of work. We never associate direction with the with the work. Okay, work doesn't have a direction. Okay, see, vectors quantity, also gets cancelled. Correct. For example, if you go from place A to place B, okay, or you move an object from place A to place B. So in order to move the object, you are applying some force on the object. So certainly some work is being done in moving the object from A to B. Let's say, for example, you did 500 joules of work in moving the object from A to B. Okay. Now, in the next part, you apply, like now you try to move the object from B to A. So again, some work is done in moving object from B to A. Suppose you did another 500 joules of work in moving the object from B to A. If I ask you, what is total displacement of object when it goes from A to B and then returns from B to A? What is total displacement of the object? This we did in ninth standard. Can you tell what is the total displacement of the object when we go from A to B and then back to A?
Zero.
The total displacement is zero. Because displacement is a vector quantity, it get cancelled, like a positive displacement and a negative displacement gets cancelled. Okay, because positive has one direction, negative has opposite direction. But the same is not true for work. In case of work done, okay, we can say work is done like When you go from A to B, you did 500 joule of work, and then while coming from B to A, the force again did 500 joules of work. So total work done here is 500 plus 500, that is 1000 joules. So it is a scalar quantity. So it is undergoing a scalar addition. Here I will just like to specify one point that in this case I'm assuming when it is going forward I'm applying force in this direction, and while I'm returning, a reverse force is acting in the opposite direction. So it is not that the force is acting in the same direction throughout the journey. Okay, while going it is in the forward direction, while coming it is in the backward direction. How is let's just even define the unit of work. Okay, since work is equal to force multiplied with displacement, and we know unit for SI unit for force is Newton, SI unit for displacement is meter. So we can say work done is Newton into meter. Newton into meter has another name. Okay, it's also called as joules or joules. So SI unit for work is joules. Is joules the only unit of work, or no? There are other units of work also. We can also have CGS unit. So I write SI unit here and CGS unit. Okay, in CGS unit, force is nothing but unit for force is nothing but dyne. Okay, and force for displacement is centimeter. Therefore, CGS unit of work becomes dyne centimeter. Okay, another name for this unit is erg. All right, relation between joules and erg. Okay, we can start with 1 joule. They may also ask you to derive the relation. So I'm just doing the full derivation so that you understand the derivation as well as you can remember the value. So 1 joule is equals to 1 Newton multiplied with 1 meter. Now we convert Newton to like to dyne. If you remember from last year, we know 1 Newton is 10 to the power 5 dyne, and 1 meter is 100 centimeter. So we can say therefore this is 10 to the power 7 dyne centimeter, or 10 to the power 7 erg. This is one object. We are applying force on this object, uh, let's say 50 Newton, and bodies undergoes a displacement of 20 centimeter. Can you find the work done in joules and work done in erg? So first in joules, what's the work done? So for joules, we do force into displacement,
Yes, sir.
and force is 50 Newton, and 20 centimeter means zero point 0.2 meters. Convert this to meter. Okay, therefore this is okay 10 Newton meter or 10 joules. Clear?
Yes.
Now to convert to work, you can just multiply this with 10 to the power 7.
10 to the power 8.
Yes, the real expression for work. The expression which we learned till now, like work is force into displacement, is only applicable in one case. When the direction of force and displacement is same, means you push an object and the object goes in the direction of the force applied. But it is not necessary that on always like the displacement of the object is in the direction of force applied. Like for example, if this is a toy car, okay, and you're trying to move it by using a string attached to it. So you're holding it like this in an inclined position and you're moving forward. Okay. So technically the string is applying force in this direction, but the car is moving in this direction, isn't it? Okay.
Yes.
So sometimes we see that the force and the displacement are not in the same direction. Or it also happens sometimes that on the same body, multiple forces are acting. Some forces are acting in the direction of displacement and some are not acting in the direction of displacement. So, how do we calculate work done due to each of those forces in such circumstances? It says here the expression of work in such situation is work is equals to force into displacement into cos theta. Okay, theta represents the angle between force and displacement. Now, in this case, what when you see the force is like this, it is just being pushed horizontally. The displacement is in the direction of incline. Angle between them is theta. This is theta, right? Okay, so in this case, the actual expression for work F into S into cos theta. Okay, the amount of work done is product of force, displacement, and the cosine of angle between them. A body is acted upon by a force of 20 kgf, gets displaced by 1 meter. Calculate work done by force when the displacement is in the direction of force at an angle 60° with the force and normal to the force. So a body is acted upon by a force of 20 kgf. So they have given force here in kgf. Force is 20 kgf. Okay, last year also we came across terms like kgf. So simple thing you understand, if you have force in kgf, you multiply that with g to find force in Newton. And here value of g is given as 10 Newton per kilogram. Okay, so therefore I can say this is 20 into 10 or 200 Newton. Clear? So force, if it is given in kgf, to convert it to Newton, you just multiply it with the g value. If you at all have this confusion that, sir, last year we had g as like 10 meter per second square. Okay, why is it written like Newton per kilogram? Anyone has this doubt?
Yes, sir.
Okay, see, this is very simple. Newton per kilogram, we know Newton is kilogram into meter per second square. So if you divide that by kilogram, kilogram and kilogram get cancelled and you get meter per second square. Therefore, Newton per kilogram is same as meter per second square. Is that okay?
Yes, sir.
One, force is in the direction of, sorry, displacement is in the direction of force. So here work done would be force into displacement, that is 200 Newton into 1 meter, that is 200 joules. When it is at an angle of 60° with the force. So this here is force into displacement into cos theta. So 200 Newton
So cos 60 or just cos?
cos 60. Yeah, I'll put because here it's given no 60°. So
Okay.
60°, cos 60°. My bad. Okay, you remember from again trigonometry last year what is value for cos 60?
So is it 1 by 2? I
Cos
don't know.
60 is what?
Or
Cos
2.
60 is 1 by 2. So
Okay.
2 and 2 gets cancelled, 100. So
100.
100 joules. In this last case, it's given that means displacement is normal to the force. I mean, like force is in this direction and displacement is in this direction. Something like this. So angle between them is 90°. Okay, so here we can say again 200 Newton into 1 meter into cos 90. Now from trigonometry last year, we know that cos 90 is 0.
0.
Therefore, this work is 0 joules. If force is in the direction of displacement, okay, or displacement and force are in the same direction, in that case, theta, the angle between them is 0. Okay, or theta is missing here. So theta is 0. Then work done is equal to force times displacement. Just force into displacement because cos 0 is 0. Okay, so that is this first case. Like the object is like this. You're applying force in this direction and the displacement is also in the same direction. In this case, work done is positive and maximum. Maximum value of cos theta is 1. So cos value fluctuates between plus 1 and minus 1. Cos 0 degree, okay, cos 0 degree is 1, and cos of 180 degree is minus 1. So since this is maximum 1, maximum value of this product would be f time s, right? Because if I put any other angle, and if the ratio becomes less than 1, like for example f into s is 100, okay, if this is 1, the total value would be 1, would be 100. But if the ratio becomes half, the net value would become 50. So if I take the ratio, any other ratio which is less than 1, the overall product would become less than 1. Clear? So hence it is said that, so hence we can say that at x is equals to 0 degree, we will get maximum angle, like maximum value for work done. What if the displacement is normal to the direction of force applied? If a coolie is holding weight on his head and he is moving on a horizontal surface, what is work done by coolie or against gravity? Gravitational force act in the downward direction, and see, since he is not lifting the object, okay, since he is not lifting the object, we can say he is not doing any work on the object against gravity. The entire weight is acting in the downward direction, okay, and he is moving in the horizontal direction. So the balancing force which the coolie is applying is in the opposite direction, like this, on the weight. So he's applying force in this direction, while the movement is in this direction. So since force and displacement is perpendicular 90 degree, therefore work done is 0.
Zero. Okay.
So if displacement is 0, then the work done is 0. Okay, suppose if a body, like, see, what is work done? Work done is force times displacement. So if the net displacement of body is 0, then we can say force work done is 0.
Zero.
Okay, but here I will just like to point out one thing. See, this logic is only applicable when force is continuously acting in the same direction. When the ball is projected upwards and it then returns back to the same height, what is work done by gravity in this process? Okay, by which force? By the gravitational force
And
or the weight. Okay, now tell me one thing, like when this object started moving upward or during this upward journey, at any point in the journey, what was the direction of weight or the gravitational force?
downward.
Downward. Okay, and what is the direction of weight when it is returning back?
Downward.
When it is returning back, then also it's downward. During this journey, for even one instance, do you think that the weight stopped acting on the body, or Earth was continuously pulling it?
Continuously pulling.
Okay, so see, in this situation, I can say that the net work done by gravity is 0 because the constant force acted on the body, but the displacement became 0. Initially, body was going in the upward direction, so there was positive work, and then later when it was returning, the work done is negative. Sorry, while going it is negative and while coming it's positive. How is it that? I'll come to that point also in a while. But overall work done is 0. Okay, so please understand this. Like the point I'm trying to make is, see, when we say displacement is 0, work done is 0, it means, okay, displacement is 0, but force is acting in the same direction. Uh, what is work done when a body is moving in a circular path? Okay, what is work done on a body when it is moving in a circular path? So I've heard a lot of time people telling, sir, since it's moving in a circular path, displacement is 0, therefore work done is 0. Have you ever heard this thing?
Yes. Yes, sir.
Okay. See, this is first of all completely wrong. Okay. This logic makes no sense. Okay. Let's see. See, the question was body is moving in a circular path. Not always the displacement is 0. Displacement is only zero when it reaches the same point. So the question is not that what if a body covers one circle. Okay, the question says the body is moving in a circular path. Moving in a circular path doesn't mean it is at the starting point. It might be anywhere on the path, isn't it? So isn't it wrong to say displacement is zero in a circular path?
Yes, sir.
Displacement is only zero when it reaches the same starting point. It is not zero during entire part of the journey. Therefore, this logic itself is wrong. Okay. Now, suppose this body is moving in a circular path, and suppose it is right now at this instance here at this point A. Okay, it's moving in an anti-clockwise direction. So at this very moment, like when it is at A, the motion is tangential to the circle. Like at any point, it tries to move. Like for example, here at this very instant, the object is trying to move in this direction. Okay, here it's trying to move in this direction. Okay, there is a very tiny displacement which I cannot represent on the picture, but it is like in that small tiny section, it's moving in this direction along the tangent. Do you agree with me? See, at any instance, like at any instance, like suppose here in this instant, the small movement of the object at that instance would be along the tangent. Okay, it won't move this much. I'm just trying to show the direction. It will just move maybe this much, a little bit, tiny bit, but the tiny bit of movement would be in the direction, tangential direction. Okay, so now this explanation makes more better sense if I say that at any moment, see, in this case the force direction is always changing. Like here force is this direction, here also force is this direction. So direction of force is continuously changing, but also the direction of displacement continuously changes. But at any instance, if you see the direction of force and displacement, they are perpendicular to each other, and therefore in a circular motion work done is zero. Am I clear?
Yes, sir.
So this is a better explanation for this. Okay, I'm emphasizing and saying this because I've seen a lot of times student making mistake. Sometimes teachers also make mistake in explaining this point.
So
And
you say because of centripetal and centrifugal force.
just you can say centripetal force because centrifugal is a acceleration. Say centrifugal force is a virtual force. Okay, so you can just say in a circular motion at
Yes.
any instance, angle between the centripetal force and the displacement at that moment is 90 degree. Okay, therefore work done is zero because we know whenever the displacement and force is 90 degree, work done is zero. See, when I say displacement is zero, that clearly signifies that force is not changing. Okay, because the restriction is only on displacement. I'll tell you another example just to clarify your doubt, what I'm trying to tell. Okay, so that you don't get confused with these small points. Okay, I'll just erase this for now. Okay, in the starting, on the very first page here, okay, when I started this lesson, I gave you an example. Suppose you're applying force of 50 Newton on a body, okay, and the like in this direction, and body goes from A to B, okay, and this is 2 meters, let's say. What is work done in this process?
So can you repeat?
What is work done in this process? Like 50 Newton force, and the body moves by 2 meter in this direction from A to B.
100 joule.
100 what?
Joule.
100 joules. Okay. Now pay attention. I am changing the situation. In next part of the journey, okay, next part of the journey. Now body is at B. It has reached B. Now it is starting from B and it is migrating towards A. Okay, same 2 meter distance. Okay, it's going like this. What is work done in this process? Same 50 Newton force.
Same value.
Same 50 Newton force, 2 meter displacement, but this time from B to A. How much is work done here?
100 joule.
100 joules. So what is total, like total work done of like on the body in A to B and B to A?
200
Joules. But
joules.
okay, listen very carefully what I'm saying. Isn't total displacement zero when it goes from A to B and B to A?
Yes, sir.
Then how is work done zero? Isn't this statement contradictory?
Yes, sir.
So this statement is contradictory because we changed the force. While going, we took a right direction force, while coming, we took the left direction force. And that's what is not allowed. Okay. If a displacement is in the direction opposite to the force, then work done is minus time F into S. Okay. So here in this case, it says that suppose a body is moving in this direction, and like that's the direction of the displacement, and force is acting in the opposite direction. Is it possible? Can you give me an example where body is moving in the right direction, force is acting on the left direction? Is it possible?
No, sir.
See, it is possible. Like suppose you are in a car. Car was already moving in this direction. It was already moving. And then you apply brake. What is the direction of force applied by brake?
Backward.
Backward. Brake applies backward force. Okay, when you apply brake, does car all of a sudden start moving backward, or it tries to slow down in the forward direction?
Um, if we like put it suddenly, then it jerks and goes
Yeah,
back.
but no, just assume that you're gradually applying the brake. So when you gradually apply the brake to slow down the vehicle continue to move in the forward direction, right?
Yes, sir.
So isn't under the influence of brake force, car is still moving in the opposite direction?
Yes, sir.
So it is possible that force and displacement is in are in opposite direction. If the object is already moving, and if you apply a force on the object, okay, the force will try to slow down the object, but it will continue to move in the same direction for some time until it come to a rest. Okay,
Yes.
so in this case, work done is negative. So we can say work done by friction is friction. Sorry, work done by brake is negative in this case. So now, if displacement is in the right direction and force is in the left direction, angle between them is 180 degree. So my equation for work becomes force into displacement into cos of 180. Okay, but 180 is minus one, so this is f in minus time f into s. Clear?
Yes, sir.
Okay, I will just like to recap that example where I was throwing the object upward and it returns to the same level, but and the question was what is work done by gravity or gravitational force or weight. Okay, see in this case when the object is going upward, force is acting
Downward.
downward. So in the upward journey when it's going up, work done is negative because they're opposite to each other. Okay, so suppose the work done on body is, okay, let's say this work done is, just take a example, so let's say minus 50 joules while going up. Now when the same body returns back, okay, this time displacement is downward and force is also, weight is also downward. So here work done is positive, so work is same plus, okay, is same plus 50 joules, and therefore the total work done is, like for going up and coming down by the gravitational force, is 0 joules, 0, minus 50 while you're taking it up and plus 50 when when it's coming down. So net work done by gravity is 0 because in the upward motion force was opposite to displacement, and in the downward motion force is in the direction of displacement. Clear?
Yes.
Okay, that is what
So
you,
then displacement is
displacement is 0 here, yeah. See here displacement is 0 like in this case, and there's a constant force acting on the body, therefore we can use this rule that since displacement is 0, work done is 0.
yes, sir.